Yeah, friends. One simple rule which we need to understand is or a common sense. See, we assume that coupon rate is 12% and the market rate or the required rate of return is 10%, which says that market, if I invest my amount in market, I'll get a return at the rate of 10%. Whereas if I invest in this particular bond, I'm getting a return or I'm getting a coupon interest at the rate of 12%. So my bond is offering me an interest or a coupon higher than the market rate. So many people will be attracted in this bond. So this bond gets demand. Everybody want to purchase this bond. Everybody wants to invest in this bond than to invest in the market which is offering a low rate of interest. So demand for this bond increases. Many people will try to buy this bond, purchase this bond, so value of this bond increases. So though the face value or par value is 1000, the rate at which I purchase this bond will be more than 1000. That is, I'm purchasing this bond at 1050. So I'm investing 1015, purchasing this bond, and in a period of 3 years I'm getting 120, 120, and in the last 1120. So I am earning some profit, but while paying this amount, though the face value or par value is 1000, I am paying 1050. That is, this bond is being sold at premium. Why? Because the coupon rate is more than the market rate or required rate of return, which increases the demand for this bond. Similarly, in the earlier example, see here he says the par value of the, I mean, we are discussing MTM. Here he says the face value is 1000, whereas market value is 850. So by this we can easily assume that face value is 1000, market value is 850, and coupon rate is 8%. Since market value is less than the face value, that is, there is no demand for the bond, nobody wants to invest in this bond. That is why this bond is being sold at discount, that is less than the face value. This means coupon rate is less than the market rate or less than the required rate. So what we need to find in this is YTM, which is nothing but market rate. So we can clearly come to a conclusion that this YTM is obviously more than this coupon rate, because since coupon rate is less than YTM or market rate, the market value is being at 850, that is less than the face value. So YTM will be definitely more than 8%. So looking at the options, eliminate one or two which is less than 8, and remaining the other options you can substitute in this. You can arrive at the value of R, which is nothing but YTM. No need to remember all those formulas. Only one formula always is face value is equals future value is equals to present value into 1 plus R whole power n. This holds good for annuities. This holds good for bond valuation. Same formula holds good for capital budgeting also. That will be our next topic which we'll be discussing. So in bond valuation, value of the bond or market value of the bond is nothing but the present value of all the future inflows which are derived from the bond. Then current yield of the bond is nothing but coupon interest divided by market value of the bond. Then comes YTM, yield to maturity, is nothing but the rate of return earned by the investor if I am holding the bond till maturity. How to calculate YTM? It is nothing but the market rate or required rate R in the formula of market value. That is nothing but market value of the bond is equals to present value of all future cash inflows, where inflow depends upon the coupon interest, and the denominator R or market rate is nothing but YTM, which we need to find. Now based on this we have some theorems, that is bond value theorems. Once we'll have a look at that. When required rate of return is equals to coupon rate, then bond value will always be equal to par value. That is nothing but when this coupon rate is equals to the market rate, then bond value will always be equal to par value, or market value will always be equal to par value. Similarly, the other two cases which we discussed, when coupon rate of the bond value is lower than the uh, sorry when required rate, market rate is more than the coupon rate, that is your bond is offering low interest than the market rate, then what happens, what will be the value of the bond? Yeah, definitely it will be lower than the par value. Why? Your coupon rate which is being offered on the bond is low compared to the market rate, so no one will be interested in purchasing your bond, so there will be no demand for your bond. Your bond will be sold at lower value than the face value, that is the bond will be sold at discount. So when required rate is or market rate is more than the coupon rate, bond will be sold at discount. Similarly, when required rate is less than the coupon rate, or reverse, when coupon rate is more than the required rate, then bond will be sold at premium. Then always one more is bond prices inversely proportional to YTM. That is, as YTM increases, the bond price decreases. See, this can seen from this formula also. What is the bond price? Bond value is nothing but present value of all future inflows, right? And this denominator R, this denominator R is nothing but the YTM. So as this denominator increases, this value decreases, that which implies that market value of the bond or value of the bond decreases. So as YTM increases, value of the bond decreases. So YTM and bond value are inversely proportional to each other. Then there are some three more theorems, that is nothing but given a difference between YTM, then change in bond price, how does these affect, those are small issues only. Just give a reading for this, I'm giving here, just give a reading for this, but important is 1 2 3 4, easy to remember. Clear? Now then, coming to another small topic called duration of the bond. What is this duration of the bond? First I'll go to the definition, then I'll explain it clear. Duration of the bond is that holding period of the bond at the end of which interest rate risk is eliminated. Now what is this? See, in bond, we take an example of a 3-year bond having a coupon rate of 10% with market rate say at 8%, par value 100. In this case, I am getting 10 rupees, par value 100, 10% coupon rate, 10 rupees each year, right? So I am assuming that this 10 is invested at market rate every year. So as soon as I am getting 10 in the first year, I am investing this 10 in the market at market rate 8%. Second year I am getting another 10, I am investing this. So in bond theory, we assume that the coupon which we are receiving will be invested at the market rate immediately. So now assume what happens if market rate increases. So from 8% market rate goes to say 11%. Our coupon remains 10%. So what happens, earlier market rate was 8%, coupon rate was 10%. So our bond coupon was being paid more than the market rate. So my bond will be sold at premium. So if my face value is 100, my bond will be sold at, let us assume it, 120, because my coupon rate is more than the market rate. Now what happened, my market rate has been increased to 11%, whereas my coupon is at 10% only. So now here market rate is more compared to the coupon rate which is being offered. So now the bond will be sold at discount. So since it is face value is 100, let us assume this market value of the bond will be at 90. So since, because the based on the fluctuations in the interest rate in the market, my bond value also fluctuates. But I assume that in this case, when my face value was at 120, I was investing my coupon, my 10 rupees coupon which I am receiving at 8%. Whereas in second case, I am investing this 10 at 11% in the market. Earlier I was investing at 8%, but now I am investing my coupon inflows at 11%. So though I am losing in my value of the bond from 120 to 90, yeah, though I am losing on my bond value from 120 to 90, but I am earning on my investment of coupon interest. That is, bond value 120 from bond value has decreased from 120 to 90 from case 1 to case 2. That is because of increase in market rate from 8% to 11%. Whereas return on my coupon payments which I am investing was it, if I am investing 10 at 8%, I used to earn 8 paise. But now I am investing this 10 at 11%, so I am earning 11 paise. So my this income on this coupon investment has increased, though my bond value has decreased. So duration is that holding period. So there will be a particular time where this decrease in bond value will be exactly compensated by this increase in investment of my coupon inflows, return on my coupon inflow investment. So that period is called duration. That is, duration is the that period by holding the bond up to which results in elimination of interest rate risk. That is, whenever there is a fluctuation in market interest rate, that also affects my bond. But if I hold my bond till the period called duration, interest rate risk is eliminated on my bond. That's it on duration. Then we'll go for capital budgeting. What is capital budgeting? Capital budgeting is nothing but various methods to assess where to invest my capital. See, I have some capital, I have some amount, I need to invest somewhere. I have say 3 projects. So out of these three, which projects, in which project I need to invest money so that my return will be more, or say I'll end up in profits. So the methods which suggest in which project I need to invest or where to invest my capital are this will be discussed in capital budgeting. So capital budgeting is basically the methods to decide upon profitability of a project or viability of a project in which we can invest our capital. So there are basically the methods are classified into two types. One is discounted cash flow method, second is non-discounted cash flow method. In discounted cash flow method, we'll consider time value of money. That is, we know that rupee earned today is more valuable than rupee earned tomorrow. That is, money has got some time value. That is, with the duration of time, value of money changes. Why rupee earned today is more valuable than rupee earned tomorrow? Because if I'm earning 1 rupee today, then I am earning 1 rupee after 1 year. So this 1 rupee has more value than the 1 rupee which I am earning after 1 year, because within this 1 year I can get some interest on this 1 rupee. So at the end of 1 year, the value of this 1 rupee will be much more than the or more than the 1 rupee, because I will be earning some interest on this one. So always rupee earned today is more valuable than rupee earned tomorrow. So in discounted cash flow methods, we'll consider that time value of money. That is nothing but we'll always arrive at present value of all the future inflows. Again the same formula, same story, right? Whereas coming to non-discounted cash flow methods, we'll not consider time value of the money. We'll directly consider the future value of the cash flows as it is. We'll not consider any time value of money concept, and we'll not consider present value, future value, blah blah blah. Directly we'll take the values and we'll decide the project. Clear? So first I'll discuss discounted cash flow method. In discounted cash flow methods, we have two methods. One is NPV, net present value. Second is IRR, internal rate of return. Now what is NPV? Net present value is nothing but the present value of all future inflows. Say a project, there are 2 projects. One project is earning 10 rupees for first year, 20 rupees for second year. We'll assume life has only 2 years for easy calculation. Whereas for this I need to invest 30 rupees. I need to invest this 30. So this is cash outflow. So cash outflow is as on date minus 30. Plus these are cash inflows. Inflows are positive signs, outflows are negative signs. And always Present value is beginning of the period. So this is being invested at the beginning of the period. So present value is nothing but future value divided by 1 plus r whole power n. That is nothing but present. Today the value is 30. This I am earning at the end of first year. So its present value is 10 by 1 plus, let us assume market rate as 10%. So it is 10 by 100 whole power 1. Then this 20 divided by 1 plus 10 by 100 whole square. This value is nothing but NPV, net present value, that is present value of all cash inflows minus of cash outflow plus positive of cash inflows. Similarly, we'll take for another project also, we'll arrive at NPV. Now which project to be accepted, or in which project I need to invest capital? That decision rule in NPV is accept that project where NPV is greater than 0, where NPV is positive. So decision rule in NPV method is accept the project if NPV is greater than 0. Clear? Next, second method is IRR, internal rate of return. In this we'll find this R at which NPV is 0, that is minus cash outflow, these all are present values, plus present value of all future cash flows, cash inflows, is equals to 0. So for this, in the earlier example, market rate is not given, minus 30 plus 10 by 1 plus r by 100 whole power 1 plus 20 by 1 plus r by 100 whole square is equals to 0. Solving this equation, we will get an r. This r is nothing but IRR. This is nothing but this comparing this with our bond value theory, YTM. This R, this denominator, market rate or required rate or YTM or IRR. It's nothing but the rate at which NPV becomes 0 in capital budgeting. In bond value, it is YTM. It is the rate at which NPV becomes 0 in IRR, whereas in bond value it is the rate at which return which bond holder gets if he holds bond till maturity. So now what is the decision rule in IRR? Accept that project which has higher IRR. IRR is nothing but the rate of return at which NPV becomes 0. So whichever project is having higher IRR, that is whichever project is having higher rate of return, accept that project. In NPV rule NPV method, decision rule is accept the project if NPV is greater than 0, whereas in IRR accept the project with higher IRR. Coming to an NPV case, if the projects are mutually exclusive, if the projects are not related to each other, then accept the project where NPV is higher. That is, first rule is accept the project if NPV is positive. So if NPV is negative, eliminate those projects. You are out of 4 projects, you are end up in 2 projects where NPV is positive. Now if both are not related to each other, then accept that project where or whose NPV is more. One NPV is plus 2 and another NPV is plus 4. Accept the project whose NPV is plus 4. That is only if the projects are mutually exclusive. Otherwise, accepts all the project whose NPV is greater than 0. That is discounted cash flow method. Now coming to non-discounted cash flow methods. We have 2 methods, very simple. One is payback method, second is ARR, that is annual rate of return method. Payback method is payback period. We'll arrive at payback period. What is payback period? The period within which the initial investment is returned back or paid back. We'll take an example, that is 30 is the initial cash outlay. In the first year we are getting an income of 10. In the second year we are getting an income of say 15 or say 20. In the third year we are getting an income of say 22. So my investment is 30. This investment is getting back or return back within 10 plus 20, 30. So within 2 years I am getting back my 30. So payback period is 2 years. Take another example. Same initial investment is 10. First year I am earning around 18. Second year I am earning around 20. And third year I am earning around 25. So here first year I am getting 18, whereas my investment is 30. In second year I am getting 20. So at the end of 2 years my total inflows from project is 38, whereas my initial investment is 30. So my investment is being returned before 2 years but after 1 year. So my payback will be around 1 point something. Clear? Depending on the options we can assume. See, it is 18, only half is reached. It is almost 38, so it will be around nearly 1.76, somewhere in that. Basing on options we can take a guess. So payback period here is 1.76, payback period is 2 years. So out of these two projects, which project I need to accept? This one. Accept the project with lower payback period, that is accept that project which is returning your investment within less time. Here within 1.7 years I am getting my investment back. Here to get the same investment back I need to wait 2 years. So I'll take up this project. So payback method will arrive at, will calculate the payback period. What is payback period? The period within which initial investment is returned back. And the decision rule in payback method for capital budgeting is accept that project with lower payback period. Clear? Then coming to last method of capital budgeting, that is ARR, annual rate of return. Annual rate of return is nothing but average profit after tax, average profit divided by average value of the investment. So profits earned by the project, all the future flows directly will take the future value. See, here we are directly considering 18, 20, or say here 10, 20, 22. We are not calculating the present value of these future cash flows. Why? Because payback and ARR are non-discounted cash flow methods, whereas NPV and IRR are discounted cash flow methods. Here we will be considering time value of the money, and therefore we will be calculating always present value of future inflows. Whereas here, since it is non-discounted cash flow method, no time value of the money and no calculation of present value. Directly will take the future cash flow values as it is. So ARR will arrive at all the average of profits. Say life is 3 years. First year it is earning a profit of 2, second year it is earning a profit of 3, third year it is earning a profit of 4. So 2 plus 3 plus 4, 9, divided by 3 years. So 3, average profit is 3. Initial investment is say 10. I assume salvage value is 0. So 10 minus 0 divided by 2, 5. So ARR is 3 divided by 5. In another case, we will arrive again ARR for that project also. I assume that ARR is 4 divided by 5. So decision rule in ARR is accept the project which has higher ARR, that is which is giving me more return. I will take that project. Average profit divided by investment. So whichever is giving me more profit, I will take up that project. So ARR decision rule in ARR is accept the project with higher ARR. Now let's sum up capital budgeting. Capital budgeting, the methods are divided into two types. One is discounted cash flow and another is non-discounted cash flow. Discounted cash flow methods will consider time value of the money and calculate present value, whereas in non-discounted cash flow methods will not consider time value of the money and will not calculate any present value. Discounted cash flow, we have two methods, NPV and IRR. NPV is net present value, that is nothing but minus cash outflow, that is present value of cash outflow, plus present value of all future cash inflows. Decision rule, accept the project if NPV is greater than 0. If projects are mutually exclusive, accept that project which is having higher NPV. Next, IRR. What is IRR? Internal rate of return. Will determine R at which NPV is 0. Decision rule is accept that project where IRR is greater. Then coming to non-discounted cash flow methods, we have two methods. One is payback method and second is ARR, annual rate of return. Payback method is we'll calculate the payback period, that is period within which initial investment is returned back, and the decision rule is accept that project which is having lower payback period. Then coming to ARR, that is nothing but annual rate of return or average rate of return. We'll calculate ARR, that is average profit after tax divided by average investment, and decision rule is accept the project which is having higher ARR. That completes our capital budgeting, and then we'll quickly skip into next topic, that is depreciation. Now what is depreciation? Depreciation is nothing but decrease or reduction in value of an asset over a period of time on using it or non-using it. That is, value of an asset decreases over a period of time. See, you have purchased a car today at a value of 100 rupees, and immediately after 3 days you want to sell that car. Can you sell it 100? No, definitely the asset value will be less than 100. Why the value has decreased? Because of time, that is because of usage. Because of usage there is wear and tear, the tires have gone on, so the value have decreased. Now assume that you have purchased the car, put it in the shed, you have not at all used it. Can you, when you are selling it after 3 days without using it, will you get the same value? No. Even if you are not using the asset also, the asset value is decreasing. That is, the decrease in value of an asset over a period of time, though we use it or don't use it, is called depreciation. Clear? Now we have methods to calculate depreciation. We have three methods. One is straight line method, second is written down value method, WDV method, or declining balance method, and third is sum of years digits method. And there is one terminology in depreciation called sinking fund. What is sinking fund? Sinking fund is the fund in which every year depreciation what we are calculating will be accumulated into sinking fund, which will be utilized at the last, that is at the end of life of an asset, to purchase new machinery or to replace the existing asset. Clear? And remember that depreciation is always a book entry. Actually the money is not going out of the system, only in the books the asset value is being decreased by way of depreciation, but the money remains in the system. There is no actual cash outflow. Clear? Okay. Now for the accounting purpose we need to arrive at depreciation. So for that we follow some methods. So we have three different types of methods. First method is straight line method. In straight line method, the annual depreciation is constant every year. Clear? The annual depreciation remains constant every year. Now how to calculate the depreciation? In straight line method, depreciation is nothing but purchase value of the asset, that is the value at which you are purchasing the asset, minus salvage value. That what is salvage value? That is the amount which you get when you sell the asset after its life. See, assume that there is an asset whose life is 3 years, and you are purchasing this asset at 100 rupees. Life is 3 years and the salvage value is say 20 or say 10. Easy for calculation. That is, after 3 years, after life of this asset, if I am selling this asset, assume this asset is a car, I am purchasing car at 100 whose life is 3 years. So after 3 years, if I want to sell this car, I will get only 10 rupees. So salvage value is the value which I get at the end of if I sell my asset at the end of its useful life. Clear? Now how to calculate depreciation using straight line method. So straight line method, depreciation is your purchase value minus salvage value divided by number of life, that is nothing but 30. So this is the constant depreciation, and every year your depreciation amount will be same. So first year your depreciation is 30, second year also your depreciation is 30, third year also your depreciation is 30. Clear? Fourth year? No fourth year, because life of asset is assumed as only 3 years. So depreciation will be charged only for 3 years. After 3 years, I'll sell that asset for 10 rupees. Clear? So in straight line method, depreciation is calculated as purchase value minus salvage value. Salvage value will be given in the problem. If salvage value is not given in the question, assume salvage value is 0. Then depreciation as per straight line method will be directly purchase value divided by number of life, number of useful years of life. Clear? and depreciation remains constant every year. Now, declining balance method or return on value method. Here, depreciation percentage is assumed. Here, depreciation amount is constant in every year. In return on value method, depreciation percentage is constant every year. So, we'll assume rate of depreciation say at 10%. So, in the same example, if my